Alright, I'm making this video for you today so that you can still get some notes, and even though I am not here, this PowerPoint will be on my website as well as this video if you just want to watch the video again and get all my explanations, or just get the words that you miss. So follow along as I go. Simple harmonic motion and waves. Some of this is going to be review from what was in the video that you watched yesterday. Simple harmonic motion, we talked about this a little bit before the break, refers to any object that oscillates back and forth. So, as you learned from the lab, we did a little pendulum, and the pendulum swing back and forth. So they go back and forth, and it oscillates. And as we learned in the lab, it exhibits simple harmonic motion. Alright. And as we also figured out, a pendulum is defined as any mass suspended from a fixed point and allowed to swing freely back and forth. That's a simple pendulum. And the period, this is a very important definition that you get, is the amount of time, and it is always measured in seconds in this class. And it's time required to complete one oscillation or one complete cycle. Factors that affect the period of a pendulum are the length and the acceleration due to gravity, which is why the equation for the period of a pendulum, the period is equal to the square root of the length of the pendulum divided by little g, because these are the only two things that affect the period of pendulum if we ignore friction and the mass of the rope. So that's pendulums. Waves are simple harmonic motion because the particles of the medium that it travels through, they oscillate back and forth. Anytime you have a wave, the particles of that medium, or whatever the wave is traveling through, oscillates. So you look at this word, medium, is a very important word. This does not mean between small and large. Medium is a material through which a wave propagates. If you think about it, sometimes people talk about spiritual mediums. There are people who claim to be able to converse with the dead, so the dead people talk through them. They're a medium for that. A medium of any kind is a material through which something propagates. The plural word for medium is media, which is why the news media is called media, because it's what the news travels through, or music media, all those things, the way that we get that information, and it's called media. We call it media because it's something through which something propagates. So when we're talking about waves, the medium is the material through which a wave propagates. Definition of a wave is a rhythmic disturbance that carries energy through a medium. One of the most important things here is that it carries energy. That's what waves do. They transmit energy. So if you want to get energy from here to here, and you don't have anything to do, you send it in a wave. Alright? So, there are two categories of waves that you need to be familiar with: mechanical waves and electromagnetic waves. Mechanical waves are waves that are in physical media. They require a medium. Electromagnetic waves are exactly what they sound like. They deal with electricity and magnetism. Light, radio waves, microwaves, infrared, those are all electromagnetic waves. Sound, water waves, waves in a spring, those are all mechanical waves. So, let's talk about electromagnetic waves for a second. Electromagnetic waves consist of alternating electric and magnetic fields. If you remember from our discussion of electricity and magnetism, an electric field produces a magnetic field. So if you have an electric current, it produces a magnetic field. And if you have a magnetic field that's changing, it produces an electric field, which produces a magnetic field, which produces an electric field. And if you see, the electric field produces magnetic field, which produces electric field, which produces magnetic field, which produces electric field, and it just keeps going. Alright? That's what makes an electromagnetic wave. They do not require a physical medium. That means they can travel through empty space. That's very advantageous for us because all the energy we get from the sun is electromagnetic. That's an in there. All the energy we get from the sun is electromagnetic. it gets from the sun to the earth with traveling through empty space. It does not have any physical medium to travel through. Alright, we're going to spend a lot more time talking about electromagnetic waves in more detail when we discuss light, because light is an electromagnetic wave and it's the one that we're going to deal with the most. So we'll talk about electromagnetic waves a lot more then. Mechanical waves are what we're going to focus on right now. Mechanical waves must travel through a medium. They cannot travel through empty space. Alright? So if we say that sound is a mechanical wave, that means sound cannot travel through empty space. So let's say you were to go out into space and you take off your spacesuit helmet and you just let out a big yell. Alright, and you just scream. No one can hear that. So if you think about all those science fiction movies where you see things blowing up and they always have the sounds and you hear the lasers shooting, like Star Wars, you always hear the lasers shooting. If you were actually watching a space battle and you were not inside something, and you were actually sitting there watching a space battle, you wouldn't hear anything because sound cannot travel through empty space. It'd be really cool to watch, but you wouldn't hear anything. But if they made movies like that, they'd be really boring. Nobody would want to watch them. Right? There are two types of mechanical waves, as you see here. Longitudinal. In the old-fashioned things, you'll hear them called compression waves. That's what they were called most of the time, because that's what they are, and you'll see why in a little bit. And transverse waves. So these are the two types of waves, longitudinal and transverse. There are also surface waves. And surface waves are waves that happen at the surface of, like, say, the ocean, where between two media, surface of water and air, and they're kind of a combination of both longitudinal and transverse waves. And I'll show you that in a little bit more in a minute. Let's talk about longitudinal waves first. Longitudinal waves are waves in which the particles of the medium oscillate or vibrate parallel to the direction of wave propagation. It's a lot of very, interesting sounding words, big words there, but you have a spring here and it oscillates back and forth. So you notice it's got the little picture here. It shows the hand pushing back and forth, and you see parts where the wave is bunched up. That's the wave as it moves down. The particles of the wave, the springs, are moving back and forth. Okay, so they're oscillating back and forth, and the wave itself is traveling this direction. So they're parallel to the direction, or along the direction. That's why they're called longitudinal waves. Longitudinal means in the direction of the length. That's what the word means. So longitudinal, the wave travels in the direction of the length. Now, I'm going to see if I can show you with an actual spring for a second. So we've got ourselves a little slinky here. And if I move in, you see the wave. It's kind of hard to see on this video, but you see the wave move back and forth. Okay. If I just send a little pulse down, it moves the length. And what's happening is the parts of the spring, as it's moving, they get bunched together, and then they move apart. And then they bunch together, and then they move apart. So the particles of the medium, so the little parts of the spring, because the spring is the medium that the wave is traveling through, the parts of the spring just move back and forth, and the wave travels the length of the spring. So they're in the same direction. Alright, so that is a longitudinal wave. Alright. Transverse waves are waves in which the particles of the medium oscillate or vibrate perpendicular to the direction of wave propagation. And I'm going to actually give you a little bit of a Latin lesson here for a second. Trans means to cross, and verse is line. That's why you call poetry verse, because it comes in lines. So to cross the line is literally what transverse means. These are called transverse waves because the wave moves up, or the particles of the medium move up and down. The wave itself moves this direction. So the wave is traveling this way, but the particles are going up and down. And at the conclusion of this video, in just a second, I'm going to have the sub show you a second video that is actually a very familiar form of a transverse wave. So let's do that right now.